Okay, here we will start chapter 6, the loop and the string. Okay, so let me bring up the whiteboard. Okay, we actually started with the sequential programming. Sequential means follow a sequence, right? So we actually started from some program that we assign a equals 3, and then integer b equal 4, and then we do a plus b equals, I'm sorry, let me erase this. Then we do something like system.out.print a plus b, right? So this actually is so-called sequential. We follow the step 1, 2, 3, one by one, right? That's sequential, means step by step, okay? Then we have this decision box. That's logic. So we have that if a greater than 3, we do this, else we do this, right? That's decision. So in the execution flow, it's something like this. If it is yes, true, we go this way, and false or no, we go this way, and then join over here and continue, right? Sequential is one by one, and this one actually is like this, right? You make a go this way or go that way, and maybe you have a box over here as well. If you have the else part, you go either left or right, right? And this one is only one way, so you end up with this. We end up with the sequential one. Sequential one is like one by one. And get out. We have this decision box. You go left or you go right. So the part yes or true. The other part is false or no, right? Now we introduce the third kind of operation we call repetition. And it will be, we go here, and then we continue to do something, and then finish. If this is yes, we check on certain conditions. So this diamond box is called a decision. Okay, so you keep going here and then make decision. If yes, it continue. If no, it get out of here and continue here. So this is the third kind of the program structure we talk about today. And that is called repetition. So we have repetition actually repeating something. The first kind we have sequential, one by one. Second kind we have left or right, make decision, right? That's if then else statement. Now we have repetition. Repetition means that we repeat something many times. And actually we have done this before. And repetition we have while loop, while something loop. We have do while loop. We have for loop. And the most recent one, we have for each loop. Okay, we have four kind of loop. Can you write down this four?
Yeah.
Can you read it? Can you read what I write down? Okay.
Yeah.
And then today we are going to start to introduce one by one, okay? All of these four. For each.
Oh.
For each one.
Okay.
For each one.
Okay.
So here in chapter 6, we are on loop and strings, and we have the while loop, and we have increment and decrement. We have for loop. we had nested loop, and then it doesn't introduce the for each loop and do while loop, but I will add them, okay? But today I'll try to finish up to the 6.4 nested loop, and then character string will be second part for this this chapter. Is that okay?
Yeah.
Now that's a different story, okay? So that's the second part. So first part we will finish up to the loops. So wait, actually it's gone. I'm sorry. I'm sorry. You are writing, but actually it's gone. I forget that I already switched the screen for you. Are you okay with this?
Yeah. Oh, I finished writing.
Okay, then I clean it, okay? Now we do it one by one, okay? So first, let's look at this first one. The first program, I call it if and while. Okay, this one is called and then if decision box, and then I can do the same thing, similar thing. Okay. Okay, I have this if and then while loop. Okay, and I compile. The only difference, like here, I have a minus minus. Okay, so here I should write this as while loop, and here I write as if block. Okay, and I start to run. Okay, so if block run once, and then while loop also run once. That's because my condition is actually a greater equal to 3. And so it will come here. It will basically from here come to here and check yes, and it goes through here and go out and check here yes. And then after that, your A decrease. So A decrease from 3 to 2. And you go back to here check, and it's not matching the condition. So this condition we call it continue condition. Whether the while loop will continue or not, we call it continue condition. And it's a Boolean expression or Boolean value or Boolean variable. Is that okay? It's something that you check yes or no. We call it Boolean expression. So that is a continue condition, whether we will continue or not. But basically, the loop structure looks similar. So you will come here and then get to here and then get out and come here, check, yes, go into here, and then come back, but fail the check and get out, okay? So we print exactly each one of them one time. But if here I remove this A decrease, right? If I remove A decrease, what will happen? And when will you stop? When will it stop?
Never.
Never, yes. So this kind of thing, this kind of loop, we call it infinite loop. I'm sorry, I should use this one. I should use this one. This kind of loop, we call it infinite loop. That means we have certain condition, it always match. So we go in, do something, go to here, but never got fail. So it actually loop forward, 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 forward. Okay. So if you go to Apple computers headquarters, Apple computers headquarters, their address is #1 infinite loop. That's the address for Apple computer. I'm not kidding. That's for sure. That's actually is the address one infinite loop. Right? It's one infinite loop Apple. That's its address. Okay, that really is the company's address. And Microsoft is number one infinite Microsoft way.
Oh.
Okay. And Microsoft is number one Microsoft way. So there's only one way. And this guy says it's infinite loop. So Microsoft's address is one Microsoft way. So it actually don't allow other people to do business. Okay. And if you say check Facebook, you see the headquarters, the address is called one hacker way. They only hack some people's code. It's called one hacker way. Okay, this is actually funny. It's just for your knowledge. Anyway, so that people keyed in that Apple will never get out. Okay, so let's try here. If we remove that, we compile, right? We actually let me clean it. And here, that's wrong. So you see the while loop never break, right? But if you write your program somehow get into such a condition, what can you do? You remember, come to here, we have tool. Click tool, here has a reset Java virtual machine. Now stop. That means that we reset the whole program and it actually will break it, okay? And then you clean this, right? But one simply remember, what?
Like, how did you clean it?
Here, option and clear.
Oh, okay.
Okay, but here, if you remember, here it also has another saying, unlimited buffering. If I clean this one, it will have limited buffer. So let's see. If I clean that flag and I run, okay, let's keep, you actually do. It should stop actually. It should will stop somewhere. Okay, you'll stop somewhere and it will clean. Okay, but anyway, we still need to reset that. Okay. And actually, I keep this unlimited buffer on. Okay, I always keep this unlimited buffer on. And actually, if you want to save the file to some certain file, say actually here and then save to aa.txt file, something like that. For your output, type save. We type save. We save that and then go to the directory and come to here. Oh, I'm sorry. Here we have that AA over here. See, another while loop over there. Is that okay?
Yeah.
I actually save to that. But this one is not a best reader. You can open with someone like Notepad, WordPad. It will be in the regular format. There's some file format issue about the output of that file. And actually, Notepad sometimes is not compatible with a lot of tools. But no, don't worry about that for now. Just use different editor. Even Word is okay. So here, this maybe is not really useful. So here, let's do this. Let's have I equals 0. And then here, let's have I less than 1. Okay. And here, let's say I less than 1. Right. And let's do this right here. We would have here, let's say I increased. Okay. And I put I over here instead of A. I have some reason to using I. Okay. I because it's short for index. The English word index. Index is used for counting, okay? So that's index. So we have this. So here I less than 1, I will do it once, right? And right here is also I less than 1, so I come in, actually I will increase 0 for the first time come in, and then it equals 1 and it get out. So this will also run exactly 1 time, right? But if here I control this one to like 20 times, the first time come in, it will be 0, come in, print once, and then get out. So when I equals 0, we print once, right? That time we print 0, right? And then 1 come in, you print 1. 2 come in, we print 2, and then continue until it is 19. You come in, print 19, right? And then next time you increase that I become 20. Come to here, fail, and get out. So actually 20 will not be printed. So we print out 0 to 19. Totally, how many number over here?
20.
Yeah, there's a 20 number over here. So you will print out the whole thing 20 times. So let's run it. Compile. And here you actually, the if block print once and then while do 20 times. So let me change it to n, right? I can control with n and go over here. I put my n equals 5, right? So actually that is controllable now. Okay, so loop counter is controllable now. It's actually 5 times, but index increased from 0 to 4. So basically, with a number n over there, we will count 0, 1, up to n minus 1. That's a 4 in this case. Okay. So 5 actually is the ending condition, but not included. We call it ending condition. 5 is the ending index. So we actually start from 5, 0 to 5, but 5 not included. This included, okay? Some function will take that parameter like this, okay? So actually that is 5 times. We count it for 5 times, but we only do up to 4. So here, if I say I do 10 times, it will go from 0 to 9. Okay, I'll do 0 to 9. Is that okay?
Yeah.
So now let me clean it. And here I keep it 5 times. Okay, now let me create a second file called loops. Okay, and I'll delete all this. I'll delete all this, right? And then I will copy this main function over to my loops. Okay, and I'll close my if while thing. I'll save, right? So here, let me do this. Here, let me do this. Here, I set I equals 0 to reset that. Okay. And the next one, I also do. Let me see. Let me do this. Let me do for j equals integer j equals 0. J less than n j plus plus. This we call it while loop. So here, this one is if block. This one is called while loop. This one is called for loop. Okay, this is called for loop. And let's look at this for loop now. the difference of for loop and the while loop is very limited. So here we have this one, we call it initial condition. Okay, and we have initial condition over here for if function. And then here, second one, we have this one. What is this name? The name of this check-in? Do you still remember?
No.
Continue condition, right?
Yeah.
Same thing. This guy is continue condition. Okay. Third one, we have this guy. Oh, I'm sorry, I should use different color. Okay. Third one, let me use black. Okay. I'm sorry. This could. Oh, I actually use eraser. Okay, and so when I use black color, we call it update. Here, I is an update. Here, J updated. Okay, so we have initial condition, continue condition, updates. Okay, and then this while loop is equal to this for loop. Okay, now let me clean it. Okay, let me clean it. And let me go to the whiteboard. The whiteboard over here, we have while loop, so we can do while loop. But we have the integer, say let's have integer I equals 0 over here, right? So while I less than 5, say, right? Do something, and at the end we do increase. So we, right here, we have initial condition, right? Over here. We have continue condition over here, right? We have update condition over here, right? And let's do this. We have another one called for loop. Let's say integer, integer j equals 0, and then j less than 5, and then j plus plus. I'm sorry, here we don't have this, should be this. Okay. And then let me do this. Just a little bit more. Let me erase this part. Okay. And then let me do this. So we have the gray one. Initial condition is this. The blue one. The continue condition is this one. The third one, the update is over here, the same. And we may put some function or doing something over here, the green one. These two are the same. Can you copy this down?
Yeah.
But make sure that you put this J plus in one line, okay? 2 line is fine, okay? There's nothing wrong for 2 line or 3 line, but put this together with 1 line. That will make it prettier. So these two are the same. While loop don't need to have this or this, okay? While loop is flexible, but you can actually do this, and these two will be equivalent. Let me know when you are done, okay?
Okay. Okay, I'm done.
Okay, I'll erase it. Okay, now let's look at the program structure. So we actually have this one. I equals 1, right? We come here, we check I less than 3, let's say. And then we come here. If yes, we come into here, do something. And then at the end, we do I increased. And then we go back we go back to here and check it is wrong, we get out, right? So this diagram is also for the while loop or the for loop. Okay, this is this box. The purple box is the third one. Okay, it's not this one, okay? So you come here, you do this once, and then you check whether it's less than the condition, n or something, okay? If yes, we come here and do something. That something actually is the green statement we talk about. The green statement we talk about, right? And after that, we do the I increase, that's the update box. That is the update box, purple one, right? We have the purple one to update. Okay. So this one actually is the structure of having 4 integer I equals 1, and then I less than 3, and then I increase. Oh, I'm sorry, it shouldn't be that. It's like this. Okay. The structure of this guy is right here. And we know this can be converted to while loop as well. Is that okay so far?
Yeah. Yeah.
So that is the box, okay? So let's see. Let's go back to the program, okay? Let's go back to the program here. I have this, right? Then right here, I do, and I don't need to write the I increase at the end. This is for loop. Okay, this one is for loop. So my loop body will be like this. My function will be like this. So right here, the program will start like this. We count whatever been done here, done, right? Come to here, set j equals 0, and then check with j less than 5, and then come in, print it once, and then after finish, come back to update j equals 2, check the condition, get in, do this, increase, check condition, get in, increase, check condition, get in, until n is actually equal to 5, then you get out. Is that okay?
Mm-hmm.
So that's how this is will work, okay? Now let's run it once, okay? Compile, and then run, okay? And each one of them, we call it an iteration. Each one time for j equals 0 to 4, each one time we go through this. Each time of this, we go through this or go through this, we call it an iteration. It's an iteration. Totally, this goes through 5 iteration here, 5 iteration here. Is that okay?
Yeah.
Okay. And any question for this for loop? Any question for this for loop? Okay, no, right? Let's continue. Okay, I'm going to show you another loop called do while loop. Okay, now let's do this. Let's do integer k equals 0 now. Okay. Another loop called do while loop, and do, put your parentheses together and you put while, and here you say k less than n. Is that okay? So this one will be doing like this. This one is called do while loop. Okay, it's another loop. It actually, let me clean this one. The do while loop will be something like this. We have do something something here. So we have something green here, right? And then we have while. That's continued condition as well. So we have I less than 5, say. So this one is the continued condition, right? But if there is no update, you initially have I equals 0, then you go there, you would actually never get out. So this one actually is something like this. You come here, you go into the do while loop box, and you check the condition, come back to here. So it will come back to here. Okay. But then if there is no update condition, then you will actually also have an infinite loop, because you start with I equals 0, it come in, you never get out, right? You actually continue do it, and then you never get out. Unless that you have a condition to fail the continued condition, you'll get out, right? Otherwise, you will not get out, okay? So right here, you also need to have some update box here or here, somewhere in the program. Say, let's say here we have an update program. So we have I equals, I decreases, I increases, say, right? So you will go here, do something, update, and then check, and then go back, do something, check, do something, check. So the order of this program is different from the while loop. So let's see, here we have this k less than n. So here, then we can have this k increase, right? So what will happen? Let's see what will happen, okay? So actually it's the same thing. You initially have equal 0, 1, 2, 3, 4. It actually look like the same, right? Look like the same, because initially you have k equals 0, so you print do while loop the 0 iteration, and then you increase to 1, so check, okay, then we come back, okay?
Yeah.
Look like the same. So only difference for this and while loop is, okay, the while loop is actually check in, do something, update, check in, do something, update, go back, check in, right? This guy is do something, update, check in, come back. Okay, what's the difference between the two? If you look at this, okay, if you look at this guy actually you started from, it's actually a little bit, let me do this. If you do actually kind of starting from here, you check in, right? And then at the check in, you go back, I'm sorry. You go back to here, right? And then you have to do something, and then update, and then check in, right?
Mm-hmm.
The while loop is actually like this, right? It's a check in, do something, update, right?
Yeah.
Except that it do it once. This guy will at least do it once. Okay? You go into here at least once.
Okay.
So here, actually, you go into there at least once. You copy this down. Okay, I'm sorry.
Okay, I'm done.
Okay, I clean this one. And this one should be okay, right? We don't need copy this one. So
Yeah.
here, actually, you do 4 times, right? But if I moved here to here, right? What will happen? The first time k equals 1, right? So you will actually print 1, 2, 3, 4, 5 instead of 0, 1, 2, 3, 4. You see the difference? If I have an update condition before that, you see the difference?
Yeah.
Okay. And if I don't have this, what will happen? If I don't have this, I don't have the K increase, what will happen? It will never get out, right? Hello?
Yeah.
Because of what? Because K always be 0.
Yeah.
Okay? Let's try. Okay, you never get out. Okay. So in this case, we need to reset my Java virtual machine. Okay? So this one actually never get out. This one actually never get out. Okay. So that one actually never get out. But let me do this. If right here, I say K equals 100, what will happen? Actually, what will happen?
I think it would never get out because it won't get
No, actually, the first time you come here, it will get out because it never be 100. This is continue condition, not exit condition. So you have 0, you will just print once and get out. So that's why I told you it's actually at least will do once. It actually will do once. If you have no update and the condition not met, it will do once.
Okay.
Is that okay?
Yeah.
And actually here, a lot of change, a lot of things that we can do with this, okay? So today I just introduced this different loop for you. As for how this can be used, there are tons of story I cannot finish in one day, okay? You have the whole 10th grade to do AP computer science on this, okay? So don't worry about it. Now you just need to know there's a if, block, while loop, for each loop, do while loop, and do while loop will get in at least once. And then if the condition not met, it's fine. So I'll leave it like here, okay? I'll leave like this, you know, to that, because you will break and you will do not just one time, okay? Now the next one is called for each loop. Okay, the next one is called for each loop. So this one I actually will need to introduce some other things. It's called an array. What is an array? I can type this and A equals 1, 2, 3, 4, 5. This we call it array. A-R-R-A-Y. Array of integer. Okay, so it's a group of data. It's actually it's a group of data. I mean the equal sign. It actually is a group of data and 5 data 1, 2, 3, 4, 5. So let me go to this page. Okay, so right here we actually have a group data. We store it as 0, 1, 2, 3, 4. Oh, I'm sorry. I actually let me see. Let me do this. Okay. Let me erase this. I actually made a mistake. I should start from 1, okay? So actually I have this one, the data 1, 2, 3, 4, 5, but its index, say here, nothing I want to tell you. The index is actually 0, 1, 2, 3, 4. So you have A and you write down like 0. This one actually is this guy. It is actually equals to 1. This we call it an array. Array is a group of data, group of same kind of data integer. And say that actually is 0, 1, 2, 3, 4. So this kind of array, if you think about your sequence in your algebra 2, you have A0 equals 1, A1 equals 2, right? So you have AI equals what? For in this case, this AI would be I plus 1, right? Is that okay?
Yeah.
So here you have AI equals I plus 1. So that exactly is the sequence. The only difference is like sequence in your math, you usually like to start from 1. But in our Java, we like to start from 0. Is that okay?
Yeah.
That's the only difference you need to know of, okay? And in fact, because it's actually a sequence, okay? So in fact, I can have 0, 1, 2, 3, 4. I put inside here 2, 4, 8, 16, 32. That's fine, right? So actually, AI will be 2 times R I minus I order. Okay, I'm sorry. Is that okay?
Yeah.
This is my geometrical sequence in Java array format. Is that okay? Okay. This is good. Okay, that's a geometric sequence. So right here, let's do this. Okay, I have this, right? So next thing is called for each loop. Let's do this. I can do integer and then AX, and then from A, and let me don't call it A, let's call it A data, okay? And here I say, okay? So I actually, each time I get the data from A. First time I get the first data, that's actually 1. Second time I get my second data, that's actually 2. Third time I get my data 3, and then 4 and 5. That's why I call it for each loop. This one is called for each loop, for each integer in A. Is that okay?
Yeah.
So these are the 4 kind of loop we introduced today.
Okay.
Okay, while loop, for loop, do while loop, and then for each loop. Wait, it doesn't update. Okay. Oh yeah, okay. Do while loop and then for each loop. Okay. These are 4 different kind of loop over here. But what's good about, I mean, let me try something, okay? Let me create a new program called sum, okay? We studied loop, but there's no reason why, there should be some reason we do a loop, right? So the first thing we would like to do loop is like public static void main. So right here, we start this sequence, right? So we have this integer a equals 1, 3, 5, 7, 9, right? And then we do this, okay. What's wrong with that? Oh, okay. Here I must put a bracket, okay? In order, so no bracket is an integer. 2 bracket means it's an array, it's a group of data. Is that okay?
Yeah.
Okay. Then I'll do this. For int a x, right? From a, right? And I'll do this. Here I put something called sum. Starting from 0, and I say sum increased by AX, right? And at the end, I say system.out.print out, and I say sum of 1 to 5. I'm sorry, 1 to 9. And here I say it's odd number equals sum. Is that okay? So what would be the sum over here?
But there would be a lot. Wait.
I would say 25.
Yeah.
I would say this guy is 25. And then if I have 11, it would be 36. If it is like 13, it will be 49. Why? Why this will be in that way, in the way I say it actually is a summation of 2i minus 1, I from 1 to n, right? And this n, okay. So this thing will becomes 2 summation I equals 1 to n I minus summation I from 1 to n. This one's actually 1, right? So the left hand side is this guy is 2 times 2 n plus 1, right? Right hand side, this is summation of 1 for n time is minus n. So this one cancel out, and then it will be n times n plus 1 minus n. This one will be n squared. So 5 element will be 25, 6 element will be 36, 7 element will give you 49. Is that okay? You probably need to write down this one, okay? I'm teaching you a series now. So you first write the red one, okay? And then you write down the blue one.
Okay.
But I put your algebra 2 into Java, okay? So here is only 1, okay? Right here is only 1, okay? Summation of 1 by n from 1 to n. So that's taking sum of the 1 for n times, and it actually give you n. I give you this n over here, okay? And left hand side, you have 2 times n plus n plus 1 divided by 2. So that 2 cancel out. So the sum of R number equals n squared. That's the conclusion. Is that okay?
Wait, sum
of odd numbers equals n squared. Sum of 1 is 1. Sum of 1 and 3 is 4. That's 2 squared. Sum of 1, 3, 4, 5 is 9. Is 1, 2, 3 square. Is 3 square. Sum of 1, 3, 5, 7. That's 16. That's 4 square. Are you okay?
Yeah.
Sum of 1 is 1. Sum of 1, 3, that's 4. That's 2 square. Sum of 1, 2, 5, 1, 3, 5, that's actually 9. That's 3 square. See that? Sum of 1, 2, 3, 5, 7, that is actually 16. That's 4 square. Continue. Okay? Let me know when it is done. Okay? So this one is actually help you to get the sum. Get a sum for something. Okay? You can use the for each loop. You can use for loop. I will actually teach you for using for loop as well.
Okay.
Are you done?
Yeah.
So let's clean this. And I don't actually intend for so many terms. Okay, I end up with 9. So we know the sum will be 25. Okay, let's see a radical value. Right? That's actually here. I put that clean screen statement. Okay. And then right here, I clean the screen. And over here, I run it once. C is 25, right? Now, let me do another thing. That's one way to take sum, okay? Second way to take sum, let me show you. Here, for example, I have another one. I have integer array b equals 1, 2, 3, 4, 5. The sum would be how many? Actually, it would be 15, right? So we have the sum like total this time. Let's name it the total. And then for int I equals 0, I less than b dot length. I increase. And then right here, I put total increased by b of I. And then at the end, I say system dot out dot print. And I put now sum of 1, 2, 5 equals plus total. Is that okay? So what happened in this? This is actually using for loop instead of for each loop. So for loop, I say my I initially is I equals 0. When I have I equals 0, my B of 0 is 1, right? So I have 1. I have this 1 and then add to total. Total original 0, so now total is 1, right? Second time I have B equals 1, B1. My B1 actually is 2. So I add my 2 to total. Total is 1 at this moment, and then you add 2, it will become 3, right? And then I add my B2 into total. Then my total would be, B2 is 3. 3 plus 3 it will be 6, right? And then I have my B3 add to total. B3 is 4 add to total. So total become 10, right? And then I have a B4 add to total. B4 is 5 add to total. So total become 15, right? So copy this thing down, okay? That's the step-by-step data from the right to the left. One by one, you will end up with the total equals 15. First time you get the B0, that is equal 1, add to total, total equals 1. Second time you have B1, add to total, total become 1 plus 2 becomes 3. Third time I get my B2, that's 3, add to total, that is actually 6. And then B3 add to total, B3 is 4, add to total, that is 10. B4, 5, that add to total, that's 15. Okay, finish it, and then we will look at the code, okay? This is another way to take sum. The previous one for each is getting the data, catching each data, and then I add to my sum, right? This one is not. This one is like, every time I get my index, and then I use my index to like go to some certain box, and then from that box, I get my data out and take to total. Okay, each time it's like I open my mailbox, get something in from mailbox, put it into the total, something like that. And then each mailbox has a key or number. You need to open it. Is that okay?
Yeah. Okay, I'm done.
Okay, so let's look at this again, okay? So this is for each loop, you kind of initial the sum equals 0. Each time you get an element AX from A, okay? Get element AX from A, and then you put it to sum. Get it to sum, get it to sum, get it to sum. Okay, so eventually you end up with 25. This guy, same thing, I get 1, but actually initially I have the 0, and so I get the index 0 location. I get 1, take to total, and then index equals 1, I get this 2, add to total. Same thing, this one will end up with 15. Okay, so let's get out, compile, and run. Okay, that's a 15. Is that okay? Now the next one I have integer c equals 1, 2, 4, a 16, right? What would be the sum for these? What will be the sum for this?
This one.
Hey, how come you spend so much time?
31.
31, yes.
Okay.
And there's another faster way to know about this. All right, this time I changed the name to Ken, okay? It's similar to for loop, right? I told you, right?
Yeah.
It's similar to for loop, and I just try doing this, right? And then I say system.out.print line. So this one is called sum of what? 2 to the power I. Right? So when I equals 0, you get 1. Plus again. Okay? This one will get 31. Okay? It gets 31. But why you should have a better way of knowing this? Getting the result. You have 1 plus 2 plus 2 squared plus 4 squared, 2 cubed plus 2 quad. Okay? This one is actually what? Actually, R equals 2, A1 equals 1. This one is like 1, 2, 3, 4, 5. So it's like R to the order 5 minus 1 divided by R minus 1 times A1 is the S5 equals 1 times 2 to the power 5 minus 1 divided by 2 minus 1. It actually equals this guy. Right?
Okay. Yeah.
It's always true. So copy this down as well, okay?
Okay.
So you need to practice your math quick, and so that you actually can have a good sense of what is this geometric sequence, okay?
Okay.
And it's used for computers several times, a lot of time.
Okay. Okay.
Done, okay?
Yeah.
Okay, this one done. Okay, now this one's the last this summation loop I'm going to talk about, okay? So this one give you this, right? Okay, now today I promise you to teach you all kind of different loop, while loop, increment and decrement, for loop, right? Now I'm going to talk about nested loop, okay? Nested loop, I will use a very simple example. It's called multiplication table. Okay, I'll just teach you how to construct a multiplication table. 9 by 9 multiplication table, okay? Right here, I actually clean this whole thing out. Clean this whole thing out, right? So I have this public static void and is ARGS like this. Right here, I have for int I equals 1, I less than equal 9, right? My integer is starting from 1 and n is 9, right? Because I want to print a multiplication table, right? So my multiplication table should look like what? Should look like this. 1, and then this is 1 times 1, 1 times 2 is 2, 3, 4, something like that, and then 2 times 1 is 2, 4, 6, 8, something like that, right? Okay? That's my multiplication table should look like. So I started my A starting from 1 to 9. Then I have another one called J inside here for my J, integer J equals 1, J less than equals 9, J increase. So I have J, I and J, right? I have I and J. So now let's look at how this can be used for multiplication table. Sorry. I have this one, I. So my I should start from 1, 2, 3, 4, 5. This is my 5 until 9, right? Going down. So my J should be going this way from 1. I'm sorry, I use another color. 1, 2, 3, 4, 5, something, right? So each time I should have like I times J. I should print out I times J over here, right?
Mm-hmm.
I keep doing that and then doing that, but I started from I from 1 to here. But when I do I equals 1, I will do inside J from 1 to 9. So I will have I to time all of the J here. For my I equals 1, I type all of the J here. And here I increase my I actually to 2 to do that. Is that okay?
Yeah.
Is that okay?
Yeah.
So let me pull this aside, okay? So each time I get started to from here, my I equals 1, I go into here, repeat for 9 times. Each time my I always be 1, okay? And my J actually go from 1 to 9, okay? And I finish, go back, my I becomes 2. And then my J also go from 1 to 9. And then finish, go back. Again, my I equals 1. And then J equals 1 to 9. Finish, go back. Okay?
Mm-hmm.
So now let's look at how can I actually print a multiplication table. Okay? So now each time I should do system.out.print. Should I do print or print line here? I times J. Should I do print or print line?
Print line.
Why?
So it's like separate lines.
That is not a table. Now, okay, let's do this. Okay, let's do print line. Okay, I will follow your instruction. No, it's look like this. It's not a table.
Oh, never mind.
Each time you print a line, right?
Yeah.
So let me clean the table, print the whole thing. Okay, it's okay. It's okay for you to guess. Right here, we clean the table, and then we clean the whole thing. And right here, let me wrong it. Okay, it's like this, right? It's wrong. So we don't do that. We actually print this, right? And then when should I actually change the line? And here all 9 of them being done, right? So here I actually do print 9 right here. But there's still some problem, okay? I told you what's the problem, okay? But each time I print a number and then I keep doing that 9 times and then until 9 number being listed in one row, I change the line. So let's do this. There's one problem, okay? I'll show you. This problem is that the number grew together, right?
Yeah.
So what can I solve it?
You can like do plus a space.
Yeah, let's do plus a space. Okay. Compile and then run. It's okay, better now, but it's ugly shape. How can I do it? So this one actually should be printf. How can I improve this? What format should I do? Is that okay? Remember this guy? Do you remember this guy?
Yeah.
This is chapter 1 or chapter 2. Give you 2 digits, okay? I keep it 2 digits and then 1 space. Is that better?
Oh, yeah.
Right? So
Yeah.
remember what I have done so far. First time I put a number and then print line, it's actually ugly. It's just a string, right? Second time, so that you write this down, okay? First time I do print line, right? And then you will list down 1, 2, 3, 4 like this, right? Print line. Second time I do print, that's better, right? And then I have a print line at the end of this, right? So print line for every line number, okay? So you end up group together, right? Third time I add space, but that actually is tilted, right? Fourth time I use printf. Okay, I use printf. So
Okay.
I tune in for 4 times and copy this procedure down, okay? But actually you don't need to do that. If you are really good at it, it's just directly write the printf statement. Is that okay? But now copy this down when you try to tune some table or something.
Okay.
Okay? Are you done?
Yeah.
And this is called a nested loop.
Okay.
This is called a nested loop. Why? The outside I loop is like this, inside J loop is like this up to here, right? So it's nested loop. Okay? So today I give you up to this nested loop to actually finish up this chapter 6 first half. So let's look at the article, right? Okay, let's go through it, okay? We'll go through it. So the first guy is while loop, okay? N greater than 0, it go in, and then each time you decrease the n. So you will print out from 3 to 1 and then get out. Okay, so you will print this like this, okay? So that's the while loop, and then evaluate the condition. The condition is right here. Let's continue condition true or false. False, you will skip get out, and true, you will continue. Let's continue condition. So it's come here, check condition, to statement, go back, check like this, okay? For the while loop. And then that's a body. But if you don't get it out, it's called infinite loop, okay? If you don't have the update, you never get out, it's an infinite loop, okay? And then right here, you have this odd and even since you introduce this example, you study it for yourself, okay? Each time you print out odd or even, okay? So you have to study this one. Increment and decrement, we use I increase for increment. That actually is equal to, for I increase plus I plus equivalent to I equals I plus 1. Okay? If I have a y equals I plus, this one equivalent to y equals I, then I equals I plus 1. So you get the data first, and then you increase. This is called post-decrement, a post-increment. And there's another one called pre-increment, plus I. But I will save that for AP, okay? But right now it's too difficult for you. And decrement, if I minus, that means I equals I minus 1, okay? So here in the textbook, we have this. You have to read this textbook, okay? That's called increment, decrement, okay? So that's only used for, so this one actually for the update statement, okay? Next one is for statement. For statement, each time you go an iteration. I told you already, right? So here I have I equals 2, I less than equal 4, each time increase by 2. So actually it will be 2, 4, 6, 8, and I print now, okay? That actually will print now 2, 4, 6, 8. Where is it? It doesn't show you the result anyway. So basically for loop, each time you get into the initial condition, check the condition, and then check the continue condition, get in to do something and go back to update, and then check it and do it, update, check it, do it, update, check it, do it, update. You know, that's one iteration. Okay, so it's like check it, do it, update, check it, do it, update. Okay, this is the for loop structure. Okay. Okay, but if you actually this one n equals 3. Let me see what's wrong with this. The last night tried to display n. Oh, but this n is outside. Remember, one thing very important is like you have a declare a integer n over here. N is only alive within the blocks, not outside. Outside would cause the compiler error. But if you write something like integer n for n equals 1, n less than 2, right? And then n increase, something like that. And you loop like here, and at the end you print that that out, that print n. This n and this n are same one, so it's okay. But if you put that one, like this one here, this one is only okay in here. It's only okay in here. Outside you don't get it. This will cause compiler error. Okay, be careful. This is a local variable. We call it local variable, okay? But when we do AP, we'll have more. Okay, and then this is the outside the loop. The next one is the nested loop. It actually also try to do what? Multiplication table, right? It actually print out the multiplication table for you. Okay, and here you use the 4D for the printf, okay? So up to here, we finish this. We finish first half of chapter 6. And then I know you haven't done some homework. You still owe me a lot. You need to catch up, okay? But you can do it. If you finish one, send it to me. Finish one, send it to me, okay? So let me check the kind of loop you can finish. 1, 2, 3 is too hard for you now. So this one, I would have you to do 3.1, 3.2, okay? You must do it, otherwise you cannot understand it, okay?
Okay.
Okay, then that's it for today. Any questions for today?
No.
Okay, then maybe meet you next week, okay? Try catch up the homework, okay? But don't ruin your school GPA, okay?
Okay.
I want you to do it. If you finish chapters, you owe me chapter 4 homework and then chapter 5, right? And you finish chapter 4, okay, chapter 5 somehow be okay, but try to catch up, okay?
Okay.
Okay, good night now.
Good night.
Bye.